Alright, so let's take a moment to finish up this nested F-test. So really we've only talked about the motivation so far. We haven't talked about the test quite yet. But we're going to go through it by using this example that we were doing on gun mortality and region. And so our null hypothesis, remember, was that these three beta coefficients from this model are all equal to 0, because if that's true, then that means region is not associated with gun mortality after accounting for the effects of gun ownership. So let's write out a full model, which is going to be our model with at least one of these beta coefficients not equal to 0. It doesn't say which one, and so we're including all of them. Our reduced model is then the model if the null hypothesis is true. So if the null hypothesis is true, then that's 0, that's 0, that's 0. So our reduced model is just this. And so the reason this F-test is called the nested F-test is that we're thinking about this reduced model as being nested inside this full model. And what that means is that you could get the reduced model just by setting some coefficients in the full model equal to 0. So we don't have to really add anything else or do anything else. We're just setting these three betas equal to 0, and we get the reduced model. That's why it's nested in the full model. And so the formula for the nested F-stat is given here. Note that if we really wanted to get this F statistic, we could. There's nothing really special or different about it. We know how to get these sums of squares. So from the ANOVA function. But we're not ever really going to calculate this F-stat by hand. Not that it's not important, it's just that if we're going to cut something, it's going to be that. And so instead, we're just going to rely on R to perform the nested F-test for us. And what we're going to do in R is we're going to fit our full model, so that's this model with all the predictors. We're going to fit the reduced model, the model without whatever we're kind of leaving out from the test. And then we're going to use the ANOVA function to give us the output for a nested F-test. We can see this in action up here, and you'll get some practice doing your own nested F-test in the R your turn part of this handout. For now, let's just look at the output. It has a couple of things that look slightly different because the notation is just different from other functions in R. This RSS is really SSE, so this stands for residual sum of squares. That's the same as the sum of squared error. It gives us the two sums of squared errors for the two models, and so this is the sum of squared error for the reduced model. This is the sum of squared error for the full model. It gives that F-stat, so if you were to actually do that calculation on the previous page, you should wind up with this 4.5062. And it gives the p-value. And so from this output, we're really just going to focus on snagging that p-value and then making sure that we could write a conclusion in context of the problem. And so because that p-value is really tiny, I'm just going to say, all right, there's strong evidence that geographic regions, that was the variable we were testing in this nested F-test, is associated with gun mortality after accounting for the effects of gun ownership. And so we're going to kind of think that region is important to have in this model, even if gun ownership percentage is already in the model. We could list our f-stat and our p-value. All right, and so I just want to emphasize one last time. I know we talked about this in the last video as well, but it's pretty important in interpreting this output, that these p-values over here are just p-values that compare these three groups, Northeast, South, and West, to the Midwest. There's nothing in this table that compares like the Northeast to the West or the Northeast to the South. Just comparing these three individual groups to our reference group. Okay, and so the your turn for this will have you fit a model that now has an interaction between a categorical variable with more than two categories and a quantitative variable. And so you'll wind up with multiple different non-parallel lines for that model. As always, let me know if you have any questions, and I hope you have a great morning or afternoon or evening or whatever time of day you're watching this video in.